This is my video on computer technology. We want to look at a change in programming. We have to change the way we program because it's not working. Our source code is unreadable for every application we write. I downloaded a obituary from New York Times. I had to print it and it turned out to have 48 files and it was 5.8 megabytes. And all we're really doing in our browser is text lines and images. And it was divs inside of more divs, so it was probably auto-generated. This was what the page looked like. We look at our Chrome browser as an application, and it has 76,000 source code files for C and C++ only. There's probably twice that many files in all the different languages they use, and the scripting files and the make files and all the different subsystems that they separated out. Really, to me, pretty much useless as an application, but this is the way all applications are built, and the names they use are not meaningful to me. They probably mean something to the programmer. The application's constantly changing the logic, conventions, and data structures. And it's proprietary logic and proprietary data structures, so we can only have one browser, literally, which is ridiculous. For all the internet, all of our documents are in something we can't use for other purposes. And too many options. Basically, they keep adding options, and it doesn't really make things better, it makes it worse. And we have billions of end-user conventions. And so the management of 48 files, it could probably be done a million different ways by a million different people. And so our naming conventions are all different. I've tried to use some of them in corporations, and it's almost impossible. And billions of templates and files and control files. So I want to change the methodology that we do software development and start looking at compiler functions. Functions that do compile time code generation, which means we have an application, and for some reason we want to add more information than the language allows, and we'd like to add more capabilities than the language allows. This compiler function will allow us to qualify our source code that we want generated. Tell it what type of sort and what type of arc and what type of database we want, and just as a qualifier without getting into the logic. And we want to supply all missing information. So most of it's in the programmer's head. Doesn't really do us much good. He understands it for 5 minutes, and then we don't have units, which is ridiculous. We don't have fractions. We don't have mathematical equations. We don't have anything. Not as we write it on paper, put it that way. We have one-dimensional limited character sets. And we want to be able to eliminate duplicate logic. The reason is we cannot duplicate logic. That's why we only have one browser. Microsoft gave up trying to chase Chromium, and they keep adding billions and billions of little tweaks to it and change it every day. I found out the other day it did something totally different, and so I had to go ahead and change my web pages. No two programmers code the same. That's literally why we can't duplicate logic. If I was writing Chromium, I would do it totally different. Everybody else would too. And a problem will always have multiple solutions. It may have 25 different ways to draw text lines and images on the screen. Literally. I was once working on a project. It turned out to be about 30,000 lines. And I looked at it, and I said, look, let's just get it down to the very fundamentals. So I took that 30,000 lines of code down to 100 lines. Basically, it just concentrating on the capabilities that I wanted, not all the peripheral logic, like the 76,000 lines in Chromium, just in C and C++. Well, if we got down to just what we're actually needing, that program most likely go down to about 10,000 or 20,000 lines of code. Programmers use linear logic approach. So basically, we go from A to B to C. Well, that's great in the programmer's mind, but later on, if he needs to change that approach, it becomes impossible. What we see is it's either impossible, so they leave it, or it changes the capabilities that were built in. They have to eliminate them or spend months trying to modify them. Our current compilers only use the CPU's logic, means that we only have one numbering format. So our CPU number format is constant, and the capabilities of our CPU is what the compilers generate. That's it. Which means that the compilers are really only assemblers that eliminate some typing. That's all it's really accomplishing. And the organization of any project, of any application, is a programmer's personal preference, which means they may be good at it, they may be bad at it, and we're only looking at files. So with the 76,000, there is no organization there. Nothing I could ever, that anybody could really ever use. You can go poke at it, but good luck. And perfection cannot be achieved, not with 76,000. You can't change anything in there without breaking something, and you're better off rewriting it than trying to fix it. And programmers only code the very minimum that they need. We don't have units, we don't have fractions, we don't have math equations, we don't have, we have separate operations. Anyway, so, and you can see it in every function that they write. It's the very minimum they get away with. Do they do validation? Some do, some don't. Do we do range checking? Some do, some don't. Most of it is assumptions on the programmers that the values are correct. And the only way we can determine that is to run the program. We should be able to get to the point where we can actually read our applications. I want to look at a compiler function, the method I want to go to, which is a separate capability of a compiler function, which says this function will be run by the compiler to generate the code that you request. So in the braces there, any code in there will be generated. Run through databases, do whatever you want to at compile time, and generate code, blocks of code, whole application, whatever you want to do in that particular function. In here, we want to set some, all we're doing here is in line 2, we're setting values that an arc requires, which is where is the origin of the circle? Is it on the right side of the arc, or at the top, or at the bottom, or the right, or wherever? And then the sweep direction of in this context, in my application, because sweep direction for every language for every mapping system is a different direction. So we have to have that capability to set these. And this is obvious. We're saying it's counterclockwise. Okay. So basically we can change these values and the application can take effect. That's what we're after, flexibility. And then we get to a function, and here this is like any other function. The first set of parentheses is our input parameters, which is, in this case, I wanted center radius, start angle, and sweep. We have many different types of arcs. I won't get into those, but AutoCAD has a bulge, which is you go from point to point. You can put it in a line string and insert a curve by saying it's a bulge and then moving the tangent, and that creates an arc from this point to the next point. And then IBM GFIS has a parabolic arc, which is really great for fillets. It calculates the arc so it's tangent to the two lines that you're going to put a fillet from at the arc size. So you tell it the arc size, and then you say put a fillet in there and chop off the lines. And then we have a second set of arguments. These are the return values. In this case, we only have one, but we could have more. And it's going to be text, and it's a description, which is the statements to draw a sweep arc. And this arc, to generate any arc, it needs to convert it to lines. This can be either done at runtime or at compile time. So, and then we return the code to generate arc from lines, from an arc to a line string. If we wanted to use this, we would first call our arc.draw, our function. We'd tell it where the center is, the radius, the start angle, and sweep angle. And we could do this in radians or degrees, depending upon your conventions. So if you want to stay in radians, you could do that. If you want to do degrees, you could do that. At line 3, we can actually get that interface of draw, all that details about the arguments and the things. We can say if the values are required or not. And you can either do it named or positional. I think I prefer named for readability. And then on line 4, we're looking at, oh, well, I'd like to get that source code that this application created, and I'd like to see that. So we're looking at access to all the information that the compiler knows, that the programmer knows, that the user knows. You know, we know what the conventions are. He has to have the ability to change it to his organization. And we can create other applications. Here I want to create a compiler. And so I have a compiler function that says, give me the name of the language to compile. So the star says you can stop there if you want, or you can type out any or all of the rest of the name of the argument. And then we have language of the compiler, which is, okay, what I'm creating source code, what language is that? And that's going to be, for my little demo here, is Fortran 77. I can put C++ or Java or Python or whatever other language we want to generate and be able to do that. And then we can determine the type of CPU. And these input values are all text. So the user creates a compiler. So the compiler name is Cobalt, the CPU will be ARM, and we can exclude statements of subroutines. In Cobalt, some compilers have subroutines, some don't. And then we could save it. This whole system is designed to be self-organizing so that you don't have to worry about where it's going to be saved. It's already been set by the application if you want, or by convention of your system. Or we could create all compilers. This is why I like singulars and plurals. But compiler deals with one, compilers deals with all of them. So I can say compilers names equals star, and I can wildcard them, say I want all the compilers that you have, and I want you to generate all the CPUs that you have. Or I can put a name in there, or a list of names, or whatever. And so this is our programming environment for everything. So if you want to create a school management system, or a banking system, or accounting system, or air traffic control, or whatever, we can reduce, or you want to do a browser, we can reduce that to the type of browsers you actually want, or an editor. We want to get to where we have all of these capabilities into a single system. We need to remove these billions of independent applications. We really need access to all information at all times for any purpose. So, and we could create that same capability in a menu. So we could say, look, compilers, pop up your menu and show me what languages you have and what CPUs you can do now. And then maybe show me how to add my own. What do I need to do to add a new CPU or a new compiler, or make my own compiler, or things like that. So that's what we're after. We're after the end user being able to do his own modification of his own system, do it in the minimum number of characters, period. What we're after is control of your own information and your own applications. right now, all these independent applications have taken over the information that you create. Word only works on Word, AutoCAD only works on DWG files, and so on and so on. And so we have billions of these. That's why we can't share information. Oh, you want to see my AutoCAD file? Well, you have to go buy AutoCAD. How much is that? That's $45,000 or whatever, some money. And but I only want to look at it. Well, good luck. So anyway, this is where we're at. So we want to control our own information. So what we want out of any application or any computer, what we want from our computer is trust. We want to be able to trust it. We want our own security. We want everything knowledgeable. So I know that I'm looking at feet per second, or I know what that particular service actually does. I'd like to see the source code of it. I'd like in this form where I'm not dealing with hardware instructions. I want to deal with logic, and that's what I'm trying to get to. And flexibility, which means that yes, I create arcs, maybe my system. I want to put all my arcs in as a 3-point arc. That's what you want to do. Then that's perfectly legal. Some systems are like that. Basically, I've worked in mapping for quite a few years, and all mapping systems are different. They all used a different style of arc and had different capabilities. They were all great, but none of them ever used all of the capabilities, but we never know when we're going to get one of those. So when you're trying to move information from system to system, you really need to have the capabilities of all the systems that are ever going to be created. That's why we want one centralized logic base to call from, and not have everybody write all of these. Writing these arcs, I could write all 5 types of arcs in a day and have them perfect. And same way with accounting systems and banking systems and school management systems, because we're only talking about employees. Every company out there has employees. Now you don't like it. That's why I want it qualifiable. You may have a different name for your employees. You may have, account managers or salesmen. And so you can basically, you just say, look, I want to qualify the name of my employees, which is what we're doing anyway. We just don't have control of it. All right. Well, thank you, and have a great day.